Hello, this is Ernest with Zero Time Trucks in Crystal City. So today I want to talk a little bit about check engine lights and how it affects your engine. So on this truck here, it's a max force, and we did the resistance testing on the injectors, right? So we know 4 and 5 is bad, but I felt like I wanted to get some captures, and this one's at the extreme, so it'll give you an idea how it's affecting your engine. Okay, so well, let me show you some captures. Okay, let me grab my laptop out real quick. All right, so right here we have the this is cranking, not starting. So as you can see, I'm not lined up because I don't have a reference, you know, hooked up. So what is more important, what I'm just trying to show you, is that we might have some valve adjustments that we need, but for the most part, the pulls are all pretty good, right? So for the most part, we're okay. We don't have leaking valves. We don't have bad cylinders. We do have a little bit of blow by in some cylinders, but I'll show you that. So this is cranking, okay? Let me show you what it looks like running. All right, this is running. Same intake capture, nothing like it was before, right? We should have pulls on each one of these. This is marking the cylinders, right? So this would be 1, 5, 3, 6, 2, 4, okay? And when you're looking at intake pulls, you're gonna start from right here. So it'd be 1, 5, 3, 6, 2, 4. We're also working with a delta P sensor, so there's going to be an action and a reaction, okay? So this is why you're seeing this. So technically what we have is 1 and 6 is working, okay? And then 2 and 3 are working, and 4 and 5 is not, okay? But here's the deal. 4 and 5 is more of an expansion stroke, not a power stroke, okay? Because there's no combustion happening because these injectors are shorted, so it's not injecting fuel. So because of companion cylinders, so to 4 and 5, it's going to affect 2 and 3. All right, 2 and 3. So companion cylinder to number 5 would be 2, and companion cylinder to number 4 would be 3. So our pistons are going to turn slower on 4 and 5 because we have no combustion, and because we have no combustion, right, and we're technically on expansion stroke, our companion cylinders for those cylinders is going to be 2 and 3. 2 and 3 are going to be on an intake stroke. For example, 2 will be on the intake stroke when 5 is on your power stroke, but in this case we're at expansion because there's no compression or no combustion. 2 will be on its intake stroke, but because the cylinder or the crankshaft is rotating slower, it's not able to pull in the vacuum on cylinder 2 like it should. And same thing for cylinder 4. Injector 4 would be 3. Companion cylinder to number 4 would be 3. So number 4 would be on power stroke, and number 3 would be on intake. And intake, we're not going to pull in the intake like we should because our crankshaft is rotating slower than it should, meaning we're not going to pull in the vacuum like we should. Okay, so number 1 and number 6 are going to try to make up for that. So we got pulls for the 1 and 6, but we're missing the pulls for 4 and 5, and then 2 and 3 are weak. Okay, so but it's hard to see that because it's a delta P sensor, all right? But if we go back and we look at what it looked like when it was cranking, we don't have a problem, right? This is what it should look like, something similar to this, right? And we're nowhere near that. So we're gonna have rich conditions. So we're gonna have NOx problems, we're gonna have soot problems, you know, maybe, you know, in this case, running rough, low power, because we don't have the combustion, because we don't have the intake pulls that we're needing, you know. So no intake, no compression, right? So I mean, they do have compression, they're just weak, right? Didn't get enough intake to build the compression to have the combustion that we're looking for. Now, if you understood, oh, let me look at this. So we also got the crankcase. So let me see. This would be the crankcase cranking, not running. So you see how we have contribution to the crankcase, you know, blow by. Some cylinders more than others. But if we look at it when it was running, okay, so this would be my crankcase pressure, and this would be cranking. I mean running. This would be running because I got this time I'm referenced, right? So that'd be injector 1. And we do have contribution from the cylinders. Now keep in mind, again, this is delta P sensor, so there's an action and reaction, but again, it's distorted because we're not getting the contribution from some of the cylinders that we should. We would be looking at the tops, and so we're missing some, okay? It's distorted. But anyway, that would confirm again that we don't have combustion going on in the cylinders like we should. So when it comes to a check engine light, no matter what it is, it could be something small, but it's affecting other things in the engine and how it operates. We could be, you know, over fueling. We could be excessive soot. I mean, we could have low power. We could have a lot of things going on because of that sensor. So it could be something as simple as a sensor or something that's actually going on in the system. So what I wanted to show was that how it affects your engine, and this is just an example on injectors that are not working. Now, this also happens when injectors are working but not fueling properly. Our waveforms are going to be distorted because we're not pulling in, you know, the air that we're supposed to. And if we can't pull in the air we're supposed to, then we can't have the combustion or the compression that we're supposed to. And then because of that, we can't have the combustion that we're supposed to. So this is how this engine is affected, okay? This engine also has a fuel knock, so I got to get this thing primed up, got to get the battery started up, and then we'll get it started up, and then we'll go after the fuel knock. But that's another video. So I appreciate you watching.